we have to answer now why KMnO4 is such a good oxidizing agent in acidic medium. If you analyze the ionic reactions, you have them here. In acidic medium, the ionic reaction is 8H plus MnO4 1 minus plus 5 electron giving you Mn2 plus. In neutral medium, it is with 3 electron, and in basic medium, it is just 1 electron. So, you see in acidic medium, the change in oxidation state of Mn is from plus 7 to plus 2, and it is getting reduced. So, it has accepted 5 electrons. It is minus 5 here. We can see in case of basic medium, it is from now KMnO4. So, we are having plus 7 to plus 4. So, the change is minus 3. And in case of neutral medium also, we can see it is again from plus 7 to plus 4. So, in basic medium and in neutral medium, the change in oxidation state of Mn is the lowest, while in case of acidic medium, it is showing a very high change in oxidation state. Now, if the signs in the change in oxidation state is ignored, we see that the large change is observed in acidic medium than in basic or neutral medium, which implies that KMnO4 has always been a strong oxidizing agent and Mn itself has got reduced. That means Mn has given away all its electrons, maximum in acidic medium and minimum in basic or neutral medium. You will say how? Plus 7 has gone to only plus 2. That means Mn itself has got reduced, but it has lost its electrons to the oxygen atoms, and from there now the oxygen, the number of oxygen if you see that is liberated is highest in case of your acidic medium. 5 nascent oxygens are liberated and only 3 in case of basic medium or neutral medium. Now see how KMnO4 reacts with H2SO4 with H2S, means in acidic medium it reacts with H2S. Let us see, with H2S in acidic medium it gives me sulfur precipitated, and that also happens in neutral solution. But in basic medium it does not give sulfur. It gives MnO2 and K2SO4 along with KOH. Now this reaction is made use of in wastewater treatment. So we can take out H2S gas, and if it is going to be an alkaline medium, then we will have formation of MnO2, K2SO4 and KOH along with water, of course. In the previous reaction, if it had an acidic medium or neutral medium, we would have got sulfur precipitated. So the pollution of the atmosphere with H2S gas is thus minimized. In the next reaction, how does KMnO4 react with NaCl? Now here you can see NaCl reacts with KMnO4 to give me Na2SO4 and chlorine gas is released. So we get K2SO4, MnSO4 and chlorine gas is released from NaCl. Okay. So next will be KMnO4 reacts in such a variety of ways with such a variety of compounds. Yes, it reacts with sodium sulfite and turns it into sodium sulfate. So again oxidation reaction here. We saw that KMnO4 is a very good oxidizing agent in acidic medium. What about the basic medium? Does it give sodium sulfate? No. It gives Na2MnO4. And what is that? That is sodium manganate, which is not a very desirable product. But still, to study the reactions in acidic medium as well as basic medium, we need to see the difference in the products obtained by the different reactions. So KMnO4 is a good oxidizing agent, we said. And does it oxidize organic compounds? Yeah, it does oxidize organic compounds, and let us see how. Here with organic compounds we saw that KMnO4 reacts to give diols when it adds to C double bond C and with other organic compounds, it gives total oxidation of the side chain or any hydrocarbon chain that may be present. See here, for example, you can see the second side ring and that has got oxidized to give me COH plus oxalic acid. Again, with primary alcohols, we get aldehyde, and if you don't stop the oxidation at aldehyde, then it goes on to give acid. Secondary alcohols give ketones because there are no more hydrogens that can be oxidized here. In aldehydes, there was still one more over here. Tertiary alcohols don't react with KMnO4. In the next reaction, as we saw that KMnO4 reacts with alkenes or with carbon-carbon double bond compounds, and in presence of water it gives glycol or a diol and a dark brown MnO2 PPT. Now this is called Bayer's test. It is used to detect presence of any unsaturation in any organic compound because the color of KMnO4 will then disappear because it has already added across the double bond in the form of OH groups. After studying the compounds of the D block elements of K2Cr2O7 and KMnO4, there are many more compounds of these D block elements which need to be considered and studied. They form a separate branch in inorganic chemistry, that is coordination chemistry. And the different coordination compounds you see here, we write them using square brackets and they are all colored. So next time we study coordination chemistry in details.